Hello everyone, good evening. So here we shall solve some more KCET previous year questions on the chapter three-dimensional geometry. So any doubts if you have in any steps, then please write that in the comments section. Uh, we shall obviously clarify those doubts in the subsequent videos. And in any other chapter of maths, if you feel more difficulty, then also mention the name of that chapter in the comment section, so that we can give more priority on it and solve more and more questions on that chapter, which shall be helpful for your KCET exam. Also, please install our Sapience education application, where we shall upload some important homework questions based on the previous year KCET exam. The link of the Sapience education application has been provided in the description. So here it is told, if a line makes an angle of pi by 3 with each of x and y axis, then the acute angle made with z axis. So here, as you know that if alpha, beta and gamma are the direction angles of a line, suppose these are the direction angles of a line, it means that alpha is the angle it makes with the x-axis, and beta is the angle it makes with the y-axis, and gamma is the angle it makes with the z-axis. So then these are called the direction angles of the line. And then cos alpha, cos beta and cos gamma, these are called the direction cosines of the line. Direction cosines of the line. And the sum of the squares of these direction cosine should be equal to 1. The rule is that cos square alpha plus cos square beta plus cos square gamma, that should be equal to 1. So now here it is told that the angle which the line makes with x and y axis is pi by 3. So it means here it is given that alpha equals to beta equals to gamma, that is equal to pi by 3. No, sorry, alpha equals to beta equals to pi by 3. So we have to find gamma. Gamma we have to find. It means the acute angle made with the z axis. And since it is an acute angle, so cos gamma should be having a positive value only. Should have Cos gamma should have positive value only, since here it is told this gamma should be an acute angle. Okay. So therefore now cos pi by 3, cos pi by 3 is cos 60 degree, which is half. So cos alpha is cos square pi by 3, plus this also will be cos square pi by 3 plus cos square gamma, that is equal to 1. So then cos pi by 3 is half, so cos square pi by 3 will be half square, that is equal to 1 by 4. So this is 1 by 4 plus 1 by 4 plus cos square gamma, that is equal to 1. So therefore half plus cos square gamma, that is equal to 1. So cos square gamma is half. So cos square gamma is half, it means cos gamma should be 1 by root 2. So it means that the angle gamma should be pi by 4, since cos 45 degree is 1 by root 2. So therefore option B is the correct answer. Then here it is told the length of the perpendicular drawn from the point P, which is 3 comma minus 1 comma 11, to the line. This line, its equation is x by 2 equals to y minus 2 by 3, that is equals to z minus 3 by 4. So we have to find the length of the perpendicular drawn from this point to this line L, to this line L. This length of this perpendicular that we have to find. So now first we can find out the foot of the perpendicular. Foot of the perpendicular that we have to find first. Let that point be M. So any point on the line, let it be x1 comma y1 comma z1. So at any point on the line, I can say this x1 by 2, it should satisfy the equation of the line also. So it should be x1 by 2 equals to y1 minus 2 by 3, that is equals to z1 minus 3 by 4, and let that be equal to lambda, suppose. So therefore x1 should be equal to 2 lambda, y1 should be equal to 3 lambda plus 2, and z1 should be equal to 4 lambda plus 3. So therefore this foot of the perpendicular M, that will be 2 lambda comma 3 lambda plus 2 comma 4 lambda plus 3. And then the direction ratios along this line L are 2, 3 and 4. These are the direction ratios. So therefore PM is, the line segment PM is perpendicular to the line L. So I can say, that PM vector, the scalar product of PM vector dot the direction ratios along the line, I can say, which is B vector, which is 2 I cap plus 3 j cap plus 4 k cap. So PM dot B, that should be equal to 0. So therefore PM will be equal to 2 lambda minus 3 I cap plus 3 lambda plus 2 minus of minus 1, that is 3 lambda plus 3 j cap plus 4 lambda plus 3 minus 11. So that will be, 4 lambda plus 3 minus 11, that is 4 lambda minus 8 k cap. That, so PM dot vector B, that is 2 I cap plus 3 j cap plus 4 k cap, that should be equal to 0. So therefore I can say that 2 into 2 lambda minus 3 plus 3 into 3 lambda plus 3 plus 4 into 4 lambda minus 8, that should be equal to 0. This should be equal to 0. So therefore from here we can find out the value of lambda. So this will be 4 lambda minus 6 plus 9 lambda plus 9 plus 16 lambda minus 32, that should be equal to 0. Now 16 plus 4, that is 20, 20 plus 9, that is 29. So 29 lambda, that will be equal to 6 plus 32, that is 38 minus 9, that is also 29. So 38 minus 9, that is 29. So lambda will be equal to 1. So lambda is equal to 1. So therefore the point M, lambda is equal to 1. So therefore the point M will be having the coordinates 2 lambda, that is 2, comma 3 lambda plus 2, that is 5, and 4 lambda plus 3, that is 7. So therefore the length of the perpendicular PM, the length of the perpendicular PM length, that will be equal to, PM, that will be equal to square root of, now point P is 3 minus 1 11, 3 minus 1 11, and M is 2 5 and 7, 2 5 7. Okay, so therefore this will be 3 minus 2 whole square plus 5 plus 1 whole square plus 7 minus 11 whole square. So this will be square root of 1 square plus 6 square plus 4 square. So this will be square root of 1 plus 36 plus 16. So this will be, so 36 plus 6, that is 42, 42, 52, so 53, square root of 53. So square root of 53 units. So option B is the correct answer. Then here it is told to find the equation of the plane through the points. Here we have a plane and these are the 3 points on it: 2, 1, 0, 3, 2, minus 2, and 3, 1, 7, A, B, and C. So you have to find the equation of the plane through these points. So here we can find the n vector. N vector we can find n vector, that will be the normal vector to the plane. Since we can write the equation of the plane in this form, which is r vector minus a vector dot n vector, that is equal to 0, where r is any arbitrary point on the plane. R minus a means I can say pa dot n vector, that should be 0, where p is any arbitrary point of the plane. So n vector will be AB vector cross AC vector. AB vector cross AC vector. Now AB vector will be 3 minus 2 I cap plus 2 minus 1 I cap plus 2 minus 1 J cap, then minus 2 minus 0, so minus 2 K cap. Its cross product with AC vector. AC vector is 3 minus 2, so I cap, and 1 minus 1, that is 0 J cap, plus 7 K cap. So this will be equal to the determinant of I, J, K. This will be 1, 1, minus 2, 1, 0, 7. Then this will be equal to I cap into 7 minus 0 minus J cap into 7 minus of minus 2, so plus 2, then plus K cap into 0 minus 1. So this will be 7 I cap minus 9 J cap minus K cap. So this is the n vector. Now R vector minus A vector. So R vector minus A vector, that can be written as, that is A vector means I'm saying that is OA vector, which is 2 I cap, means that is the position vector of the point A, which is 2 I cap plus J cap. So this will be x minus 2 I cap plus y minus 1 J cap plus z K cap. Plus z K cap. So therefore R vector minus A vector dot n vector, that will be equal to 7 into x minus 2 minus 9 into y minus 1 plus z into minus 1, that will be equal to 0. So therefore this will be 7x minus 14 minus 9y plus 9, then minus z, that should be equal to 0. Minus z, that should be equal to 0. So therefore I can say this will be 7x minus 9y minus z minus 5, that should be equal to 0. So therefore option B is the correct answer. The point of intersection of the line with the plane is how much, that we have to find. So let's say this line will intersect this plane at some point P. So we have to find the coordinates of that point. Okay. So any point on this line, which is x plus 1 equals to x plus 1 by 1 equals to y plus 3 by 3 equals to 2 minus z by 2. Any point on this line will also satisfy the equation of this line. So let's say this is equal to lambda. So therefore x will be equal to lambda minus 1. Y will be equal to 3 lambda minus 3. And 2 minus z, that is equal to 2 lambda. So therefore z will be equal to 2 minus 2 lambda. So let's say this point P, I can say it as this will be lambda minus 1 comma 3 lambda minus 3 comma 2 minus 2 lambda. Now this point should also satisfy the equation of this plane, since it also lies on this plane, which is having the equation 3x plus 4y plus 5z, that is equal to 10. So this point will satisfy the equation of this plane. Therefore I can say 3 into lambda minus 1 plus 4 into 3 lambda minus 3 plus 5 into 2 minus 2 lambda, that will be equal to 10. So this will be 3 lambda minus 3 plus 4 is a 12 lambda minus 12 plus 5 to the 10 minus 5 to the 10 lambda, that is equal to 10. So 10 and 10, that will cancel out. Then 3 lambda plus, so 12 lambda minus 10 lambda, that is 2 lambda. So 5 lambda, that is equal to 12 plus 3, that is equal to 15. So lambda will be equal to 15 by 5, that is equal to 3. Lambda is 3. So therefore the required point P will be 3 minus 1 comma 3 into 3 minus 1 comma 2 minus 2 into 3. So this will be equal to 2 comma 9 minus 1, that is 8 comma 2 minus 6, that is minus 4. Sorry, this is 3. So 9 minus 3, that is equal to 6. So 2 6 comma minus 4, 2 comma 6 comma minus 4. So option A is the correct answer. Then here it is told if 2 3 minus 1 is the foot of the perpendicular from the point A, which is suppose 4 comma 2 comma 1. This is the foot of, so this point is point P, which is this one. This is the foot of the perpendicular that is drawn from this point. Let's say that point be M. Okay. So then we have to find the equation of this plane. Okay. So let's say the equation of the plane is ax plus by plus cz plus d, that is equal to 0. So therefore the normal vector to this plane will be having the direction ratios a, b and c. So therefore n vector, I can say this is ai cap plus bj cap plus c k cap. So therefore now am vector is parallel to the n vector. So therefore I can say that n vector, I can say that is some lambda times am vector. So it means that ai cap plus bj cap plus ck cap, that is equal to this lambda times am vector. Am vector, that will be equal to 4 minus 2, that is 2 I cap, plus 2 minus 3, that is minus I minus j cap, then plus 1, so plus 2k cap. So therefore we can take the direction ratios as 2, minus 1 and 2 along the normal. Therefore the normal vector we can take it as 2 I cap minus j cap plus 2k cap. So therefore the equation of the plane we can write it as 2x minus y plus 2z minus y plus 2z plus d, that is equal to 0. So now this point m also should satisfy the equation of this plane since it lies on the plane. Therefore if we put that, therefore we can say that 2 into 2, that is 4, minus 3 plus 2z, that is minus 2, plus d, that is equal to 0. So therefore d will be equal to, this is 5 minus 4, that is 1. Therefore the required equation of the plane, therefore the equation of the plane is 2x minus y plus 2z plus 1, that is equal to 0. So it means that that option C is the correct answer. So hope all of you have understood the solutions of all these questions on three-dimensional geometry. Uh, Still any doubts if you have, then please write that in the comments section. We shall obviously clarify them in the subsequent videos. And please install our Sapience education application also, where we shall upload some important homework questions based on the previous year KCET exam. So thank you everyone. Bye.